Hi guys, I'm gonna make you a video. I was looking around for a video on this and sometimes it takes so long to find a video that I want and I just couldn't find one that I like. So I wanted to make a video for you. So here we go. All you have to do is really just kind of watch the example and then try to do the practice problems that I've attached to task two. All right. So anyways, this is a scenario about me eating breakfast. So if you read it, it says the probability that Mrs. Soko eats a banana for breakfast is 0.4. That's the same thing as 40%. Okay. Except some of the stuff is written as decimals. 40% can also be written as 4 over 100, which obviously can be reduced. It can be written as a fraction too. So some of the examples you'll see will be written as fractions, some of them will be written as decimals, and this one is a decimal. All right, so anyways, getting down to business, what we have to do here is make a tree diagram. So, oh yeah, sorry, I was in the middle of reading reading my question, I forgot. All right, so the probability that I will eat a banana for breakfast is 0.4. The probability that I will drink coffee is 0.9. Eating a banana and drinking coffee are independent events. That's just kind of to help you set up the tree and how we do these. So we're going to start off with the fact that the first thing that's happening, the first event is the banana. So I'm either going to eat the banana or I'm going to not eat the banana. And since we're talking about this, lots of times the notation is written like this. So I'm going to use B for banana. And then down below where it's not eat banana, they use this notation, which is B prime, which means the complement of or the opposite of whatever the other scenario is. So when you see that little apostrophe looking thing, that's what it means. Okay, so the probability that I will eat a banana is 0.4 or 40%. So the probability that I won't eat a banana would be 60%, like 100% minus 40%. Another way to think of that is by taking 1 minus zero point 0.4, and that's how you get the 0.6. So event number 1 is the banana. Event number 2 is going to be the coffee. So what I'm going to do off of each of these branches is talk about the fact that I'm either going to have coffee. Well, let me write. I'm either going to have coffee or I'm not going to have coffee. So it's going to be 0.9, 90% that I will have coffee, and zero point 0.1 or 10% that I won't. So I need to do the same. Oh, and I'm going to use C, and I'm going to use C prime or C naught. Sometimes they say that too. I have to do the same thing down here off of my not eat banana branch. So I'm either going to have coffee or I'm not going to have coffee. And the probabilities aren't changing, so you just rewrite them down here. And then what you have to do is just kind of come up with all these combinations. So if I follow my path, my first path, which is I'm going to eat a banana and then I'm going to have coffee, it's going to be banana and coffee. My probabilities will be zero point 0.4 times 0.9, which is 0.36 or 36%. If I go and do my next row, which is I don't eat a banana. Oh, actually, JK, let's do I eat a banana and then I don't have coffee. So eat banana and don't have coffee is going to give me 0.4 times 0.1. So 0.4 times, oops, 0.4 times 0.1 is giving me 0.04. And then I have to do the same thing down here. Let's go green. Not eat banana and have coffee. So not eat banana, have coffee is 0.6 times 0.9. So 0.6 times 0.9 is 0.54 or 54%. And the last one is going to be don't eat a banana and don't have coffee. So no banana, no coffee. hi, you guys, there's just one little correction. I was listening to the video and I realized that I said 40% can be written as 4 out of 100. That's not true. It should be 40 out of 100. Thanks. Lots of times the notation. Okay, I'm only allowed 5 minutes for each video comment, so I ran out of time on the last one. So go take a look at my last row here. My last row was do not eat a banana and do not have coffee, and that is right here. Oops, that's right here. So it was 0.06. All right, and then all you have to do is just answer these questions. So what is the probability that I eat a banana and drink coffee for breakfast? So that I eat a banana and I drink coffee. So that is this row right here. Let me use yellow. Eat a banana, so that's 0.4, and have coffee, 0.9. And with independent events, you always multiply the probabilities. So that's where the 30.36 came from, or 36%. Now I didn't, oops, I was trying to write percent. I didn't actually have to go and do it over again. I could have just looked up here and gotten it, but I was just trying to explain it to you. All right, let's take a look at my next one. What is the probability that my breakfast includes coffee? So any one of those branch combinations that includes coffee. So I'm looking for, if I go back up, I am looking for this one because that includes coffee, not this one because it doesn't include coffee, and this one right here. So I have two of them that include coffee. So it is going to be a banana and coffee, or not eating a banana but still having coffee. So both of those have coffee in it. So I just need to go back up and look at what those percentages were. So it was 36% or 0.36. And whenever you get down to these ones where you have to use two of the combinations, you add together those probabilities. And then 0.54. So if I add those together, 0.36 and 0.54, I get to 90%, 0.9 or 90%. And I always drink coffee. It's really pretty much like 100%, but I had to make up something for the problem. Okay, last one. Okay. What is the probability that Mrs. Sokolowski does not eat a banana? So no banana and no coffee. So I think I already have that row. Let me look. No banana. Let's see if I can use, so many of my colors I already used. I'll just use black. Okay, so what was it? No banana and no coffee. So it was my bottom one right here. 0.06, which is the same thing as 6%. So I hope that it helped explain it a little bit for you. Thanks for listening. If you wanted to write that down, you could have written that down. That's up to you. You can come back and watch this. I miss you guys so much. Oh my gosh, I hope you're having an okay time during this quarantine. I know it is a long time. It makes me sad. So hang in there, you guys, and thank you for keeping up with your work, those of you that are doing it. And those of you that I have not heard from, if there's anything I can do to help you kind of learn these last few units, let me know. I'm here to help you. Bye.